All right, I'm back. Here we go, video number 2, about 10 minutes here. So colligative properties, we're still talking about solutions. It says properties that depend only on the number of particles and not the chemical nature of the particles. And I'm going quick because you could pause this if you want. Boiling point, melting point, and vapor pressure are all properties that are affected by the number of particles, and these are called colligative properties. So what we're getting into here is concentration. So concentration changes, concentration of solution, which basically means solute per solvent, right? So if I have, 1,000 solute particles in 2,000 solvent particles, or I have 10 solute particles in 2,000 solvent, right? So if I have 10 particles dissolved in 2,000 particles, right? So think 2,000 particles of water and 1,000 particles of salt. Or I have 2,000 particles of water and 10 particles of salt. That's a concentration. That the word concentration is like a ratio between the amount of solute dissolved in the amount of solvent. So this one would have a much higher concentration, right? Much higher concentration. 10 times the concentration. No, more than that. 100 times, sorry. 100 times the concentration. So there's way more particles here. So that's a higher concentration. So what colligative properties really means, I know this is like mumbo jumbo to you guys probably, but basically the boiling point, melting point, and vapor pressure, those numbers, like the boiling point of water is 100 degrees, for example. These numbers, the boiling points, for example, will go up or down depending on how many particles are dissolved. Doesn't matter what the particle is. It could be salt, it could be sugar, it could be potassium iodide, whatever. As long as it dissolves, it's going to affect the boiling point, melting point, vapor pressure. That's what this is. Okay, so I'm going to try and keep this real simple. I do have an animation to help you understand concentration really quick, and then I'll draw some pictures and explain and then show you the homework. So if I go here, so this is, I have two different animations here. So this here is concentration. Now molarity is something we're going to learn later. So don't worry about that. Just look at the color of this drink mix. Let's do copper sulfate. Well, you know what, purple. I'm feeling purple today. Potassium permanganate. All right, so we start this down. All right, so let's say we add, well, you know what, that's fine, right there, whatever. Okay, so if you have a beaker of water, all right, and they have numbers here. All right, so we'll say we have half a liter about 0.5 liters. Okay, 500 milliliters. All right, so you have water. The concentration is 0, meaning you haven't added anything, right? I just told you it's the amount of solute and the amount of solution, solvent. So that's your volume. So I think you understand there's nothing dissolved in here, so the concentration is 0. So water at this point would boil at 100 degrees. So colligative properties, it's how does that boiling point change as we add this, and that's what I'm trying to show you here. But first, I'm kind of teaching too much at once here to try and save time. Concentration. If I increase this slider and I start adding solute to this, okay, and eventually it's saturated, meaning no more will dissolve. Look what happened to the color, right? So if I add a little tiny bit, it's that kind of lightish, pinkish purple. If I keep adding solute, it gets darker because I'm saturating, I'm adding more solute. Look at the concentration. It goes from 0 and it starts to slowly go up. Eventually it reaches a point where it can't go up anymore because it's saturated, meaning no matter how much I add, it's just going to sink to the bottom. It's saturated. It can only hold so much. So that concentration is the max. But again, the concept I'm trying to show you is if I add more solute, the concentration goes up and there's more particles dissolved in here. If that one's confusing, this one's different. Same concept. All right, same thing here, right? Concentration, put that there. If I shake this up, shake it up. There you go. All right, let me do that again. Reset. So this is pure water, not a solution at all. If I put some potassium permanganate, shake it just a little, just a little. Boop. Okay, so it goes up a little tiny bit, light pink. If I add more, a little bit more, it goes up a little bit more. Color's still about the same, but if I keep adding, it gets darker because I added more solute, concentration goes up. And that's the whole point. That's all I'm trying to show you. Is the concentration of a solution will increase if you add more solute. All right, it's that ratio. And if you keep adding solute and the solvent stays the same, the concentration goes up. All right, hopefully that made some sense. So now, colligative properties states, so I'm going to write this here, that as concentration of the solution increases, the properties are affected more significant. The properties are more significantly affected. Probably affected. I'm really bad with that. I should know that, but whatever. All right. So what does that mean? Okay. Here's what that means. And I'm just going to erase this because, again, you guys can pause that. All right. So let's say I have three beakers of water. Okay. All right. 3 beakers of water. What am I doing for time? 7 minutes. All right. So let's say each one has the exact same amount of water, right? So let's say each one has 100 milliliters of H2O. All right. If I heat these up, they will all boil at 100 degrees. Okay. So let's say this water I don't add anything to. Right? So let's say I have a solute, we'll just say salt, NaCl solid, right? And we're going to add it to this one, and we're going to add it to this one. All right. This one is going to be pure water, pure H2O. That's going to boil at 100 degrees. So boiling point, 100 degrees. Okay. If I add a little bit of salt to this, and I'm going to use some terms, let's say 0.1 moles, and I'm going to add 1 mole to this. We kind of know what moles are. We're going to do math. My math and chem unit is actually after solutions, but we're getting there pretty close here. So if I add 0.1 moles, so let's say I add 0.1 moles, and that is 1, 2, 3, 4, 5 salt particles. Well, if I add 1 mole of salt here, 1 mole is bigger than 0.1, it's 10 times bigger. So if that's 5, I would have to add 50 dots over here, right? 10 times 1.1 is 1. 10 times 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, assuming I have 50 dots there, all right? The reason I'm doing this out loud with you is I think it's just better to watch that way. So if I add 0.1 mole of salt to this and add 10 times as much, right, times 10 salt to this, the colligative property, boiling point, will be much more significantly impacted. Meaning, I'll make up some numbers. Let's say this solution here boils at 102 degrees Celsius. Well, if I add 10 times the amount of solute, now my boiling point, let's say, is 110. So the whole gist of this boiling point stuff with colligative properties, and there's a little phrase in this video that I want to show you. I can't do it all in one day. It's just too many videos to upload, and YouTube will crash on me. It's too difficult, but I'll try and do this in steps and short clips, short videos. The whole concept is add a solute, boiling point goes up. Add a solute, boiling point goes up. So we need to memorize that. Add a solute, boiling point goes up. If I add particles to water, the boiling point goes up. So, pure water boils at 100. We know that. Add a little bit of salt, boiling point goes up a little bit, 102, let's say. I add a lot of salt, it goes up a significant amount to 110. Add a solute, boiling point goes up. And the reason for that there is an increase in the number of forces of attraction. How much time do I got? All right. Okay. What does that mean? Well, in pure water, all you have is hydrogen bonding. All right. That's pure water. So if you want to boil water, you're breaking that hydrogen bond. And pure water, that happens at 100 degrees Celsius. If you add salt, now you have these molecule ion, dipole, ion dipole. So all the oxygens are going to face the sodium, and all the hydrogens are going to face, I'll try and squeeze it in over here. All the hydrogens are going to face the Cl minus. So these forces here, we already learned about this, the polar water attracted to the opposite charge in the ion. So these forces are in the salt water. And water is also attracted to itself. And now you have these forces happening. So you have much more forces that need to be broken in order for the water to boil, the solution to boil. So if it needs more energy to break those forces, because there are more forces, the boiling point goes up. So let's say 105, 110, whatever. Though that number is irrelevant. The point is, you understand, hopefully, if you watch this, that pure water just needs to break its own forces to evaporate and boil. But when you have salt in there, or any solute, as long as that solute is attracted to water, right, like dissolves like, similar forces, this happens. I use salt because you guys get it, hopefully. Any solute that's in water, it's attracted to water, therefore it would never dissolve, right? It wouldn't dissolve if it wasn't. You have more forces that need to be broken. That's why the boiling point goes up. So the first colligative property is boiling point. Add a solute, boiling point goes up. Why? This is why. Increase number of forces of attraction. All right, I'm going to stop the video.